Okay, everybody can hear me? Okay, I'll get started. Thank you very much for having me today. I'm going to talk about Go modules and how they make your life easier as a Go developer. You can see the slides online at cda.ms/F V, and they're already online. I will also post a video of this talk when we're done. So the basics, there is a really good wiki page on Go modules on the Go wiki site, and it has all of the information you need to get started. I definitely recommend starting there. And there's a lot of background on Russ Cox's blog post, research.swtch.com/vgo. The original support for Go modules was called Vgo or versioned Go. Go modules requires Go 1.11. So you have two different ways to use Go modules. The first and most exciting way is to invoke the Go command outside of your Go path. That means that you don't need a Go path to do Go development anymore. And that's really exciting if you don't like the Go path. You can also set the environment variable go111 module equals on, and you can use Go modules anywhere. So we have some new terms that we need to define. We have modules. We've got a go.mod file. We'll talk about version selection and semantic import versioning. So let's start with modules. A module is a collection of related Go packages that are versioned together as a single unit. Most often, a single version control repository corresponds exactly to a single module. But alternatively, a single version control repository can have multiple modules. So generally, this means that one GitHub repository is equal to one module, but you can have multiple modules in a single repository. It's just less common. So the go.mod file is a file that represents a module, and a module is a tree or directory of Go source files that has a go.mod file in the root directory. So when you create a module, you have to have a go.mod file, and all of the directories or packages underneath that root directory are part of that module. Here's an example of what a go.mod file looks like. It has a module declaration at the top, and then require statement that includes a list of all of the dependencies for that module. You can create a new module from the command line by creating a directory, changing into that directory, then typing git init and git remote add origin with your repository name, and then type go mod init. When you have git information in your repository, the Go tool will automatically infer your module path name. So it will add the module name at the top because it knows your GitHub repository. Most of the time, I don't work like that, though. I don't create the Git repository before I create the module. So it's much easier if you just pass in the module name on the command line. So make a directory, change into that directory, and then type go mod init with a package name. That way we're manually specifying the module name. Modules, the module file stores dependency information. So you no longer need a go package.yaml file or go dep or anything like that. It's all built in directly to the go command. So in this require block, we've got a list of the dependencies of this current project. It lists a module directory and a version. The versions are semantic versions. And more interesting than anything else is that the version number is part of the module path, which means it's part of your package path. So this last one, github.com/additional/dependency/v4, v4 is part of the package name. And that's because the version number being part of the package name allows you to have multiple versions of the same package in a build. And that's really nice if you're in a big complex project where they specify multiple versions of projects, which would previously break your build, but now it's allowed. If you don't specify the version number, then version 1 is implied. So with no version number, it's version 1, but if you specify a version, then that version is the new version number. So semantic import versioning, we covered that just a minute ago. v4 is the package name in this example. It means that you can use more than one version of the same package in your build. It's been very controversial, but to me it makes sense. I just think it's a small change that I need to make and learn how to use. I'd love to give another talk about how to create versioned modules that use these version directories but share code. So I'll probably do that this week, just create a new talk and put it on YouTube perhaps. Because the fact that you have multiple directories for your versions doesn't mean that all of your different versions can't share code, because they can. So let's do a demo. I love live demos. Can everybody read my screen? Yes? No? Bigger? Okay. All right, so my Go path, if I type go env, my Go path is where? Go path is users b Kettleson go. So I'm going to make a directory outside of my Go path. So I'm going to cd into projects, and I'm going to make a directory called demo mod. And in here, there's nothing, it's empty. So I'm going to create a new module by typing go mod init github.com b Kettleson, and this will be my package name, so we'll call it demo mod. Let's see what that created for us. So we got a new module file, go.mod, and inside of it is the module name github.com/b Kettleson/demo mod. So not very exciting yet, but let's create a main.go file. And let's add things to it. I'm going to import Keith Rarick's pretty package so I can print something. And then I'll make a boring main file or main function. And I'll print hello world, which wouldn't be any different than format printing hello world, but now we have an import statement. So if I write this and quit and cat my go mod file, we remember that it was empty except for my demo mod before, and now it already includes a require statement, require GitHub kr pretty at version 0.1.0. So it went to GitHub and it looked for the latest version of kr pretty, and it automatically added it to my go mod file. All of that happened just because I use the Vim Go plugin. If I hadn't been using Vim Go, I could just type go build, and it would have updated my go mod file. And if I look at the directory, here's my demo mod file. So it built for me, and it prints hello world just as we would expect. And maybe the most exciting thing about this is the fact that we are not in my Go path. So we now have development outside of a Go path. In fact, Go path is no longer required at all. And that's really fun. If, like me, you've been teaching Go for years and spent half of your class trying to teach people what a Go path was and why it was important, now we don't have to do that anymore. That makes me very happy. So really the Go module file is a simple format that includes the modules and the dependencies and a few other things if we want to. And after we built, you'll notice here that there's a go.sum file. And that's fun because it allows you to keep hashes of the packages that you've imported. So it has the name of the package, krpretty, the version, and then a hash, and I believe this is a SHA-256 hash of that package. And then the H1 here is the first hash format. The Go team added H and then a number to allow for future expansion if we need to have a different hash. So perhaps in the future, H2 might be HMAC 256 hash instead of SHA 256. So with these hashes, that means that if your packages change on disk or they change somewhere upstream, we'll know that, and the build can fail because the contents of the package have failed. And that's good for repeatable builds. One of the nice things about the new module format is that you can use the replace command. If you're working on a project and you have a dependency with a bug or a dependency that you want to modify, previously I would go into the Go path where that dependency lives. I would make a fork of that project, but I would keep it in the projects directory with my Git as the upstream and theirs as a remote. We don't have to do that anymore, which means that my Go path can stay clean of strange forks in the wrong places, because now we can add this replace statement to the Go module file. So when we use the replace statement, we're saying take the package that is at github.com/foo/bar and replace it with github.com/fork/bar. And now it will build using references for foobar, but it will use the code from forkbar. And that's really nice. That's a handy feature to have when you're using forks or if you're developing multiple projects and each of them is a separate module. You can even use relative paths, which is great. So you can just have a replace statement that has a relative path to another directory. And Roger Pepe from Canonical created a neat tool called GoHack, and GoHack does all of that replacing for you. So if you install GoHack and then type GoHack and then a package name, it will create an editable version of that package in your home directory under a directory called GoHack, and it will automatically modify your Go mod for you and point it to your hacked version, your forked version. So here's the real excitement, and we mentioned a little bit about Athens before. One of the biggest things that changes with the Go tool for module support is that the download protocol no longer uses Git or your version control system. So previously when you type go git, it's using git clone under the covers in the Go tool. But now the Go tool is using the HTTP protocol. So when you type go git for a package, the first thing it will do is try to resolve your package name and then @v/list. And that gives it a list of available packages. Then it will try to get a version number .mod file, which is your Go mod file for your package. And if it finds that, then it will go download your code in a zip format. Now, not all services support this new HTTP protocol yet, so the Go tool will automatically convert GitHub releases and Bitbucket releases to zip format, and it will automatically serve those zip files for you. But because this new download protocol is already built into the Go tool, that means that modules at a specific version are immutable. When you create a module and you tag it, it has its hash that we saw in the go.sum file, and that means that we can use a CDN to serve Go modules. And one more extension to that thought means that we don't have to rely on GitHub or Bitbucket to do our builds anymore. We can no longer say that GitHub is down, therefore we can't work. I know, no more sword fights. So the Go tool introduced a Go proxy environment variable. And if you set the Go proxy environment variable, then the Go tool will use that proxy to make those HTTP requests. If you implement a server using these HTTP protocols for your packages, then you can serve modules using an HTTP server as long as they implement the proxy protocol. That means that you can have repeatable builds even when GitHub is down. And the best way to do that today is to use Athens, which is an open source proxy server that is written by several people in the Go community, started by my team at Microsoft. So you can go to github.com/gomods/Athens, or you can see the documentation at docs.gomods.io. And you can even use an example proxy server by exporting Go proxy equals Microsoft Go proxy.azurewebsites.net and try it today. So I think we should do that. Nothing better than a live demo of a production website, right? So let's go back to my slide. I'm just going to cut and paste. So this Microsoft Go proxy is an instance of Athens that's running on, whoa, sure didn't want to do that much. There we go. This is an instance of Athens that's running on Azure. So if we type go build, nothing really changed because we have all of those files cached from our last build. So let's go into Go source, and you can see in here, where is it? Here we go. See the mod directory under Go package? If I remove that, that gets rid of my whole module cache. Now, if I type go build again, it's fetching all of those packages from the Go proxy at Microsoft, and it built our file. And it still works. So the awesome thing about that is GitHub could go down and this would still work because modules are immutable at every version. You can run a public proxy, so you can have an Athens instance that's available to the world, or you can run this behind your corporate firewall and use it for fast cached local builds. If it takes a long time for you to get to GitHub because GitHub doesn't have a mirror close to you, then this will be a lifesaver, making your builds significantly faster. Athens also has the idea of exclude and include lists. So if your corporate architects have determined that it's not okay to use a particular package, you can put that in an exclude list, and Athens won't fetch those for you, and it will cause your build to fail. And that's a thing that many corporations prefer because they want to make sure that the code that they're shipping in production has been reviewed by legal and other teams. So you can go get and play with Athens today if you want, or you can use our test instance on the Azure websites. and I just did that demo. So my call to action to you is to use Go modules today. You can do that by setting the Go 111 module equals on environment variable, or just work outside of your Go path and it will turn itself on. You can use a public proxy server, or you can run your own proxy server. The proxy specification is in GitHub on the Go repository, so you could even build your own proxy server if you want to. That's all I have, but I would love to take questions if you have some. Yes, absolutely. The example that I had of replace showed a relative path here, but you can change that to say /users /b Kettleson /something /bar. So you can use an absolute or relative path here. No, you have to use replace because the module name is distinct. The package name would give you a bad import. Sure. No, Athens only serves the HTTP protocol for the Go download files, so it will serve module files, the info file, and then the source code as a zip. So no binaries. And I don't know, honestly, if I would trust binaries built by some random internet server. I would have to think about that for a while. Possibly, but you would think of Athens as the tool that makes your CI process go faster. And if you're already using CI, then you would already have a second repo. Because Athens is just a web service. It doesn't need its own GitHub repository. No. No, it doesn't force you or require it, and it doesn't help you either. It just serves files. In fact, you can use Athens on any private repository as well. It doesn't have to be for GitHub repositories. You could use it for a local GitLab instance or Git or any other VCS instance. Athens doesn't care. Very much, yes. Which means that your clones are really slow. And Athens would keep all of that. The complication that you have with a monorepo is if you want to have package versions, module versions in subrepositories. And definitely go to the wiki and look at the section where it talks about having multiple packages in the same, or multiple versions in the same module. That's somewhere in here. Locally, you still use GoGet, and GoGet uses Athens as a proxy. So the build process uses GoGet, but GoGet is talking HTTP instead of talking Git. No, the cache directory is actually hidden inside your Go path. So if you go, my Go path is Go. If you go to the package directory, see the mod directory here, mod. That's in my Go package directory mod. And that's where all of my cache lives for packages that I've downloaded using the Go mod tool. So there's correct. And you don't have to have a Go path. So I could do unset Go path here. Of course, the Go path is going to automatically default to the local Go directory because it just does. It defaults. But I'm not inside my Go path. My directory is in projects demo mod, and that's not in the Go path. And I can still type go build, and it works because it's using the cached versions of those module files. And if I were to go into my Go path, so I do have the KR directory. If I remove them and then go back to my projects directory, we can prove that it built without my Go path because the build didn't fail, even though the my Go path version of KR Pretty is now gone. So you don't need a Go path. The Go get from the Go module support puts them in a cache, and the cache currently lives in your package directory in your Go root. It's actually built in. So if you look at the Go Wiki, you can see, where is it? Anyway, if you just type go build outside of your Go path, so how to upgrade, no, that's not it. Anyway, if you've got a GoDep project and you clone it and then type go build, it will automatically create a Go mod file for you, and it will import all of the dependencies from your GoDep package file. So the go package dot, JSON and go package.lock. So the Go module project already has migration built in. I don't know about that, but it's definitely easy. I've been using modules since maybe March, since it first came out, and I love it so much. I love the ease of use. I love the simplicity of it, and so far I haven't had any huge problems with modules. I've seen a few minor bugs, but they all got fixed pretty early. I'm excited, and I wouldn't want to go back to working without modules now. Several have. The biggest one I can think of is the Go Buffalo. Moved to modules 1 or 2 releases ago. So now you can use Go Buffalo with modules all around, and that's nice. Correct. Vgo is a standalone tool that was used before Go 1.11 was released. And you can still use Vgo with older versions of Go and get the same behavior, but it's a harder workflow, and there's really no reason you shouldn't be able to upgrade to Go 1.11. So it's just simpler to use Go 111, and then all of that vgo functionality is built in directly to the Go tool. Yes, as long as they, as long as dep continues to exist, dep uses the git SHA of the repository, so dep will continue to work. And the two can exist side by side.